Okay, welcome back. Let's look at the AD curve. In the last video we derived the AS curve. It's not so much work, but we did it anyway. So now we're going to look at the AD curve. So the AD curve, we're given, well, let's write down the AS curve really quickly. It was what, pi t, no there's no t in this, just pi. Pi is equal to the expectation of pi plus fgy plus epsilon pi, the supply shock. And this was the AS curve. Okay, now we're given three more equations. So we're given y is equal to b0 plus b1g plus b2r. We're given I is equal to I bar plus alpha pi minus pi bar plus by. And, okay, and we're also given this last equation, I is equal to r plus the expectation of pi. Okay, and then it says name the equations. America's favorite game show. So here, this is the IS curve. Okay, this is like already solved. You can imagine that I could give you the desired demand equation and all of the functional forms, yeah, for the demand for investments, demand for consumption, demand for government spending, and all of that, and then you put it together yourself and you solve for this. But here, you're just getting it fait accompli, right? So, and actually, right, because this is the IS curve, you know that this is actually the Keynesian multiplier, right? This is K, because this is the reaction of output to government spending. Okay, so that's the IS curve. Second equation, this should be very familiar to you. It's the Taylor rule. This is the Taylor rule. And then finally, we have this one down here. This is totally new. This is the Fisher equation. The Fisher equation. Okay. And what's number two asks us more about the Fisher equation. Is what's the difference between I and R, literally and economically? Literally, it's the expected inflation. Yeah. So we have R, which is real inflation, right? R for real inflation. Sorry, real interest rates. Wow, I said inflation. I meant real interest. Real interest rate. And then I is the nominal interest rate. I is the, it's going to kind of go off the screen here. Let's see. Nominal interest rate. Okay. So, yeah. And then the difference between them is just in expected pi. So previously, right, when we solved the IS curve in the exercises in the first 2 weeks, we never had R here, yeah? We just put I here. And you see that the connection between I and R, so we were dropping out this expected pi term. But the truth is that it doesn't matter, right? Because when we have the Keynesian assumption, remember we started with this Keynesian assumption, which was that prices are fixed in the short term. Prices are fixed. And so if prices are fixed, then that assumes that pi is equal to 0, yeah? And if the agents in the model know that prices are fixed, then the expectation of pi is going to be 0. So under this Keynesian assumption, the nominal interest rate and the real interest rate coincide. They're perfectly equal. But then in this setup now, where we're going to introduce short-term variations in the price levels, then we are going to see that there's a bit of a spread here. So when we plug in for R here, we're going to have to be careful and include that expectation term, which is not quite the next assignment. That's coming up. We'll do that in a second. But first we're asked about the signs of B0, B1, B2. Okay, so B1, as we noted, this is K. So, I mean, B0, is probably positive. Yeah, it's probably a safe bet because Y is positive, so the net, whatever. Like, whatever. Great analysis, thank you. Remember, B0 is built from all of the constants in the consumption demand equation, the investment demand equation, right? And so the base level of consumption has to be bigger than 0 because consumption has to be bigger than 0. The base level of investment is probably going to be bigger than 0 because it doesn't make sense that the natural state of the environment is to be in debt. So taking all that together, then the B0 is greater than 0. I guess you can imagine it's less than 0 if like the TR0 is negative, right? If there's like a negative trade balance. Whatever, don't think about it too much. But let's just assume it's positive. B1, we know for sure is greater than 0 because we know that B1 is K, right? And we know that K is bigger than 0. It's sort of close to 1. And then B2, we have to remember that B2 is less than 0, right? Why? Remember, this comes from that equation like I is equal to, what's called big I 0 plus, and then we always had a coefficient like E E is what we used before. Let's say dy plus EI, right? And we said that this EI, this is like the price of investment for firms, so that if prices go up, investment goes down. Yeah, so E is negative, and this B2 is just a rebranded E, so B2 is negative. Okay, so that's our analysis there. And then we're asked to solve for a single equation, y as a function of pi. Okay, let's clean this up a little bit. So yeah, asking you to think about those signs just so that when you do static analysis, when we do the comparative statics later on after we've solved the model, you need to be able to reason about what's positive and what's negative. So you can think about the effects of different things on different things. Okay, so our goal is to get y is equal to a function of pi. I see a y here, but I don't see a pi here. I mean, we need to bring in pi is here, and we can get it in via I. Yeah. So let's start with y is equal to b0 plus b1g plus b2r. Okay, and we want to substitute for this r. We'll rewrite the Fisher equation to be r is equal to I minus e expectation of pi. So let's plug that in. Y is equal to b0 plus b1g plus b2I minus b2 expectation of pi. And now we want to bring in this, and we'll put it right here. So we get that y is equal to b0 plus b1g plus, I'm going to factor through, yeah? So we'll have b2 I bar plus b2 alpha pi. Now I'm going to have minus b2 alpha pi bar. And then another b2 beta y. Okay, so I did I bar is here. I did alpha pi bar with a minus sign, and then by. Okay, but we're not done. We also have this term left at the end. So minus b2 expectation of pi. Pretty messy, so let's do a gathering, right? We like to gather up terms to make our lives simpler. So let's call delta. Let's define delta, and let's put together all of the constant terms. Okay, so b0, b1g, b2 I bar, minus b2 alpha pi bar. Yeah, I'm going to leave out expectation of pi because I know that eventually we're going to have to plug it into pi. Yeah, and so we'll be able to gather terms there. Also because maybe we're interested in expectations, studying expectations. Like what's the effect of expectations on inflation? So it'll be nice to leave it out. But that's kind of a personal choice. I'm just going to choose to leave it out. And I'll leave out pi as well because that's an endogenous variable. You never want to gather the endogenous variables into these collection terms. So we're going to define delta is equal to b0 plus b1g plus b2I bar minus b2 alpha pi bar. Okay, and then our y becomes y is equal to delta plus b2 alpha pi minus b2 expectation of pi plus b2 beta y. Okay, and so we have a y over here and we have a y over here. We need to gather them up and make some space. We need to gather them up. So we'll have, so bring it to the left, right? So y minus b2 beta y is equal to delta plus b2 alpha pi minus b2 expectation of pi. And then factor, so we can write this as 1 minus b2 beta y equals dot, 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 and then we'll just divide over. And there's a b2, yeah, I mean, whatever. So we'll have delta over 1 minus b2 beta plus b2 alpha over 1 minus b2 beta minus b2 over 1 minus b2 beta expectation of pi. And that is the answer. We're done. We check our slides here. There's an answer in the slides. And you see we have 1 over 1 minus b2 beta. Okay, 1, 2, 3. I did not collect into the delta term here, so you kind of have to squint and turn your head sideways. But what's important is that there's a b2 and an alpha on pi. Let me see that, b2 alpha. There should be a pi here. That's kind of a big mistake. Okay, good. There's a b2 alpha on pi, and then there's a b2 no alpha minus on expected pi. So we're good. There you go. And then Okay, we're asked what's the effect of future inflation on output? I mean, it appears to be negative, yeah, but we can't quite say that yet. So this is kind of a premature question because expected inflation also affects pi, right? So expected inflation affects inflation, and inflation is right here. So there's a second order effect that we don't know. If you were going to ask, for dy d expectation of pi, yeah, there's a chain rule term that comes out from here. So you need to be careful. So you can't quite answer that. But our expectation is that there's a self-fulfilling prophecy effect, right? Because here it's positive. If we expect inflation in the future, then there will be inflation in the future, yeah, because this is positive. And then if there's inflation, inflation reduces output in the future. Sorry, inflation today reduces output. That's that idea of the Phillips curve of like having a downward slope between outputs and inflations. So our expectation is that the expectation of pi will reduce y, but maybe not necessarily. And in fact, the analysis could go the other way, right? And I think we talked about this in class, that if I expect prices are going to go up tomorrow, then I should just spend money today, right? Because B2 is negative. So here's where it's important to think about the sign of these things, right? We have minus B2 here, but B2, remember, B2 is negative. So actually, this whole term is positive. So if expected inflation goes up, okay, first off, inflation is going to go up. So this is negative. So you have a negative effect because inflation is going to go up because expected inflation went up. But then you also have an effect where people know that people think prices are going to go up tomorrow. So they're going to buy things today, and that's going to stimulate the economy today. So you have these two dueling effects, and we need to finish solving the model to pick them apart. Okay, and then it says, actually, this is the inverse of the AD curve. The AD curve should be in y pi space, not pi y space, so we should flip it around. And I guess we can do that really quickly. It's not so bad. Just need to clean this up. It's sort of horribly unreadable right now. Let's rewrite what we have. What we have is y is equal to delta over 1 minus b2 beta plus b2 alpha over 1 minus b2 beta pi minus b2 over 1 minus b2 beta expectation of pi. And since we already gathered terms up nicely, it's really easy to just flip-flop, right? So we're going to get, we want this to be positive, so let's bring all this stuff to the other side. So we'll have b2 alpha over 1 minus b2 beta pi is equal to, and then I'm going to subtract this over, and I'm going to subtract this over. So we'll have y plus b2 over 1 minus b2 beta expectation of pi, and then minus delta over 1 minus b2 beta. Whoops, or beta 2b, b2 beta. And now I just need to multiply by the inverse of this. So we'll have pi is equal to 1 minus b2 beta over b2 alpha y. So then the b2 betas cancel, and the b2 cancels. So we're just going to get 1 over alpha plus expectation of pi over alpha. And then here we have delta. So we'll get delta over b2 alpha. So that should be pi. And we can check in the slides to see how we did. So we have 1 over alpha b2. 1 over alpha b2. We have an alpha coefficient on expected pi. We should have an alpha coefficient on expected pi. Did I make a mistake? Did I make a mistake? We have a b2. Where did this alpha come from? Ah, this shouldn't be here, right? No, it should be. We have a b2 here. Ah, yes, because I didn't factor through. Okay, look. So I didn't factor through this expression. So if you look here on the outside, we have 1 over alpha b2. We have a b2 here, so that would cancel with the b2 here. We just have 1 over alpha. We have 1 minus b2 beta over alpha b2 on the y. And then the delta, which is a bunch of this stuff, we have 1 over alpha b2, which is everything. So we're good. We did it right. Great. I'll see you in the next video.